Hey, it's Mr. Lum again, and today we're going to be doing a little bit of solubility and stoichiometry and how we can use solubility and stoichiometry together and some of the questions you might get on a test. Anyways, here's a question that we have here. It says a solution containing barium ions, and what happens is you add some sodium sulfate until no more barium sulfate precipitates out. We know that barium and sulfate precipitate out because of our table right here. So barium and sulfate have low solubility and therefore it's going to precipitate out. So we have that, and then what we do is, what we're given is we're given the volume of the solution, which happens to be 25.0 milliliters, and the mass of the filter paper by itself, which is 1.21 grams, and the mass of the filter paper plus the solid. So here is what is happening. We have a beaker full of just Ba2+. Now, what is put into this beaker is some sodium sulfate. Okay. Now, sodium. This is what this is going to be. This is going to be a spectator. So we can just pretty much ignore this. And so what we're going to be putting into this beaker is pretty much just sulfate ions. So what goes in here is this, and then what happens is you get a beaker that has a precipitate in it. Okay, so we get some solid here, and this solid is barium sulfate. Okay. What we then do is we take this solution and we put it through a filter paper. So here's our filter, and then in here we put a paper in here. Okay. Now this paper right here, this paper that I drew blue right here, weighs 1.21 grams by itself. We then take this and we put it through here, and then out comes a solution that has just water in here, and all the barium sulfate is left in this paper. And so after this paper right here, the paper plus the barium sulfate equals 3.75 grams. And then the question asks, calculate the moles of barium sulfate and calculate the original concentration of this cation right here. Okay, so now that we know what is happening, what we're going to do is we're going to calculate some of these things. So let's clear our board. Okay, so here we go. So now that we know what's happening, we're going to calculate the amount of moles of barium sulfate. So the filter paper, the solid plus the paper is 3.75 grams. Now we only want to know the mass of the solid. So the mass of just the solid is going to be 3.75 grams minus the paper, which is so minus 1.21 grams, and so we have grams of just barium sulfate right here. Now we're going to convert this grams of barium sulfate into moles of barium sulfate. So how we do that, we just use a little stoichiometry here, and we times this by 1 mole of barium sulfate is equal to, and I already calculated the molar mass of barium sulfate, which happens to be 233.4 grams per mole. So 3.75 minus 1.21, and then we're going to times this by or I guess divided by the molar mass in order to get the moles of barium sulfate. And that happens to equal 0.0109 moles of BaSO4. Okay, so here's our answer right here. Okay, so 0.0109 moles of BaSO4. Now the second question, part B, asks calculate the original concentration of the barium ions. So how we're going to do that is, well, we know the volume here and we know the moles, and concentration is just reported as moles per liter. So we're just going to simply go 0.0109 moles per liter, and we're going to change this into liters, and so that's going to be 0.0250 liters. Now this is moles of barium sulfate, and the question's asking us just barium ions before we added the sulfate. So before we go ahead with this calculation, I just want to show you what this is looking like. So what we have here is barium sulfate, and if this was to dissolve, you'd be left with right here. Now here's the equation right here, and as we can see, it's a 1 to 1 to 1 ratio. So if there was 0.0109 moles of barium sulfate, and before this crystallized into Ba2+, I guess this would be more of this kind of reaction. There would be also this many moles of barium in there. So since it's a 1-to-1 ratio, the amount of moles of barium sulfate is going to equal the amount of moles of just barium. So we can leave this as is because it's a 1-to-1 ratio, and this should give us the concentration of Ba2+. And that's going to equal, and I already did this calculation ahead of time, and that is going to be 0.435 moles per liter, or in other words, molarity of Ba2+. And here's what our answer is. Okay.